Hi guys, welcome to Learn Electronics Repair. Today we're going to talk about, and in fact practice, changing QFN chips. So that's these sort of chips. Now if you look at this one, you'll see a couple of things. First of all, it has a dot, so it has an orientation. This tells you where pin 1 is, or at least which way around to fit the chip. This is a larger one here with more legs, okay. And then it has what look like small legs at the side of it. In fact, you can feel them if you rub something across them. But these are not actually pins on the chip. This type of chip, QFN, means quad flat no leads. Okay, a little bit closer on one. In fact, let's put it under the microscope. There. So as I mentioned, these that look like legs on the side of the chip are actually not legs at all. They are solder, but the actual pads on the chip are underneath. And here is another one. Okay, you can see it, this one. Same thing. So soldering these requires a different technique than soldering, shall we say, more normal surface mount devices. And the only way you can realistically do this is to use hot air. It's not possible to get your soldering iron underneath there to solder the pads. I used to think that you could do it from the side by tacking the chip down and trying to run solder underneath, but what you also need to realise is these chips almost certainly will have a pad or more than one pad underneath which attaches them to the board. And that needs to be soldered as well. So let's play around with this and let's try changing one of these chips. This one's near the edge of the board. So first, how to remove it. Well, the key factor in being able to work with these chips is practice. Yeah, you're not going to learn this without practicing. I would suggest you get something like a scrap graphics card. That's what this one is. Old graphics card is a scrap one. It's been salvaged for various parts before. And use this. Otherwise, something like laptop motherboards, desktop motherboards, more recent ones, scrap ones. If you can pick them up for basically next to nothing, you should be able to. Then use those, okay? And practice until you can do this correctly, because I think at first you'll see people doing this and you think, no, that won't work. The chip will blow off the board, whatever, various things. I won't get the position right. But let me show you how I learned to do this, and then, as I say, practice, practice, practice. So as with other things, I'm sticking by this point I make. The only reasonable way to do this is to use a preheater plus hot air. Yes, you can do it with just hot air. It's difficult. Some of these boards, especially things like these graphics cards, are very thick PCBs with a lot of internal layers, very heavy PCBs, and you need to get a lot of heat into this before you can desolder this chip, or for that matter, resolder it. If you try to do that from one direction, either heating from below, and bear in mind there's a lot of components under here, or heating from above only, the chances are you will bubble the PCB. The PCB itself will fail, the various layers will separate, you get like a bubbling effect. And once that happens, it's game over. There's no real way to fix that. So guys, use some sort of preheating. Now, these things are about €40, but you don't need to use something like this. All the preheater is any method that will get the PCB up to about 100, 120 degrees, something like that, a little bit more if you're lucky. You could use a hot plate, a griddle, something like that. In fact, I'm going to be doing a project shortly controlling one of these from something like an Arduino, so we can actually just take a hot plate. I'll see what I can find at the car boot sale. Yeah, you could put the whole board in the oven and warm it up, but personally I wouldn't do that. It's not very good for the capacitors and other components. This board, by the way, you'll notice is also warped. Do you see that? Warping the board, yeah. So another reason why this is a scrap board. This is probably being put in an oven before now. Another thing you could use is something like a piece of stone. This is like the sort of thing you find sometimes in restaurants or places where you have a hot stone, you put your steak on and you cook it on the hot stone. Like a granite slab. It's like kitchen area stuff. You can find stuff like that, probably second hand again. Stick that in the oven, get it up to say 120 degrees and just arrange some sort of frame or some other method by which you can suspend the board above it, yeah? So the hot plate can be anything that will get the board warm. And this is something we'll do. We'll try and make some Heath Robinson jerry-rigged hot plates and we'll try them in future videos. But for now, we're going to look at this technique. Because this is going to fall off the end of the hot plate, I'll just balance something under here to keep it level. And I always put a thermocouple on here, or a thermometer meter. I mean, you could use thermal camera or one of these laser thermometers. I put a thermocouple on the board because I can actually see the board temperature properly. And I know when I get it up to about 120. But the temperature isn't that critical, as I say, if you're using some other jerry-rigged method. There is my thermometer, so you can see that's the ambient temperature of the workshop with the aircon on. It is, after all, mid-April. It's getting pretty warm now, well over 30 degrees on a lot of occasions in the day. So this is the chip here. You need to decide which direction you're going to remove this in, and the way to do it, if you can, is in the direction where you're less likely to collide with any components if it slips rather than coming directly upwards. Thermocouples here, I mean, it's not next to it, but it's touching the board. That's the main thing. It's in the general area. As I do mention, the temperature is not that critical. I just want to get this board to about 100 or so. So I'll switch the preheater on. Start to warm it up. This is not a sprint, guys. This is like more of a marathon. The idea is not to get that thing as hot as you possibly can, as fast as you possibly can. You don't want to warp these boards, yeah? Just let it take a little bit of time. You may think about putting aluminium foil or capped on tape around here. Personally, I prefer not to, especially when I have a clear direction in which I'm going to take this chip. By putting capped on and such like, you actually just make it harder to get heat into the board, okay? Likewise, adding leaded solder or low melt solder or chip quicker is not going to help you here, because there will 99% chance be a pad directly under this, which you can't add your chip quick or leaded solder to. But what you do want to do is add flux. Okay. You also want the board to be fairly stable, so it's not going to wobble. Yeah, because that's just making life difficult for you. This is my flux, NC559ASM, okay. It says Amtech, but this is knockoff stuff from AliExpress. Works fine in my experience. So while we're chatting, we can see that's up to about 76, 77 degrees, 75. I can now turn the preheater up a bit. When it gets up to about 100 or so, I'll put the preheater onto maximum and then I'll come in with hot air. Now you need to just consider, yeah, are you right or left-handed or ambidextrous? I'm right-handed, I'm pretty good with my left hand, and that's through years of doing this sort of thing, but I'm right-handed, so I'm going to come in with the tweezers with my right hand and the hot air with my left hand. Hot air, I'll show you. Where is it? Yeah, it's down here. Quick 861DW. I have it set to 450 on full airflow. Now, a lot of people prefer to have it set a bit lower than that. I prefer to keep the temperature higher, but hold it a little bit further away from the chip. All this comes down to what works for you, and the only way to find out is not really, shall I say, listen to other people. Well, yeah, listen to them, watch what they do, but when you try it, find what works best for you, okay? And there's more than one way of doing this. I know absolutely you guys will get to the comments, and that's great. because other people watching will watch me, they'll listen to what you've said, and they'll try, hopefully. I mean, if you're going to learn this, you've got to try, yeah? So, I'm waffling away. The thing isn't really getting any warmer. I'll turn the preheater higher. This preheater is a bit limited to how much heat it can actually get into the board. Probably not really big enough for things like these graphics cards, but hey, it's what I have. I think, yeah, this is just actually come away a little bit from the board. That's probably what it is. Yeah, that's like, you see, I've lost connection with the board. So it's about 109 degrees, right. I've turned it up to the maximum now. I'm going to come in with my left hand with the hot air. Because I'm practicing, I'm not really too worried about knocking all the components off, but obviously practice until you don't, yeah. I'll do my best. It'll take quite a bit of heat to do this. There. Now I've turned the preheater down. You can see the pads that are underneath here, yeah? I used to believe that you have to clean all this off and apply fresh solder. I've discovered for me it's better that I don't do that. But what I will do is a bit more flux and do this while the thing is still warm. Yeah. Do all this as one operation if you can. Don't like kind of come back at another occasion and have to warm all this up to replace the chip. Yeah. So I'm just going to get a little bit of leaded solder. A bit of fresh solder on the pads. Let me see what I have. Okay, I have a solder bridge. I'll just deal with that. Okay, solder bridge is gone. Now, I'm far better doing this with my optical microscope with 3D vision. I don't have this because I'm trying to show you guys, so maybe not quite as good as usual. Let's see. So, thermocouple, where are we at? We're back about 110, okay? This is my chip. Now, you'll see it's nice and clean. If you have a fresh chip, I suggest that you tin all the pads first. So hold this in one of these helping hand things, tin all the pads first, and then solder it, okay? Now, I used to believe that the main problem with this was trying to get the thing perfectly aligned. I would try and tack down one edge. It's not easy to do that, okay? So what you want to do is use the surface tension of the solder itself. So get the chip somewhere nearby. Yeah, it can stay there for a moment. Put it the right way up, of course. This is your replacement. Okay. Make sure you have it aligned the right way round. So we had it in one on ours that was like a chamfered edge, I believe. No, actually it has a dot on it. So to solder this on, we shouldn't need to add any more solder than that. We warm up the area again with the hot air. Have some fresh flux on this. Okay. I don't need to exactly melt the solder, just get it close so it's nice and warm. Now, if I take my chip and put it roughly in place, okay, a little bit closer than that, but roughly in place. So Okay, so I've got it on there fairly close. Just try to get a little bit closer than that. Yeah. You're not going to do this exactly, you just want it close. Okay, that's not bad. Now we need to come in with the hot air. And what's going to happen, guys, is the surface tension of the solder is going to pull it into place. The flux should stop this from blowing away, and I'm on full airflow, yeah? I'm holding the hot air maybe an inch or so, 3 centimeters or, no, yeah, 3-4 centimeters above. I'm heating. And what I'm looking for is the chip to sort of kind of like float around a little bit and then pull itself into position. You see the solder at the sides of it? Try to do this so you can see it as well. There, look. Can you see that it's centered itself on there? That's soldered. Look, you can see now it's cooling down a bit. I can move the board by pushing on that chip, okay? The chip is firmly attached to the board now, but personally I would say that isn't the end of the job. What you should do now is go around the edges of the chip with your soldering iron, a little bit of fresh solder, and you'll find that you get a much better, or at least better looking connection if you want this to look like the original. So effectively you're flow soldering down the sides. We're just going to use flux. We're going to warm the whole area up again a little bit with hot air just to get the thing warm enough to solder, and then get in there with the soldering iron and do it. So let's do that, and then we'll have a look to see how the job comes out. So to do this, guys, fresh flux on it. Yeah, I've got plenty of flux on that. Okay. Warm the whole area up with the hot air. Not enough to melt the solder, but enough to get plenty of warmth in so your soldering iron can do the job. Okay. Like so. I'm going to use my C210. It's a much smaller tip. It doesn't have quite the power of the T12 and the BC3, but these QFNs normally have a lot of very close by components. We don't want to knock them off the board, so just a little bit of solder. Soldering iron is set to 380. A little bit of solder, and then if you got it nicely warm, you'll be able to just drag along these edges like this without causing any solder blobs or bridges. Okay. If it doesn't work, then you don't have it warm enough really. Okay, down this side. So I'm just dragging a little bit of solder, and that's it. Now let's clean this up again and have another look under the microscope. Just before we check out the final results, I'll just show you again the equipment I'm using. So as I mentioned, quick 861DW. This is set at 450 degrees, 120 airflow. I have my T12. This is a KSGER T12. I've had this for some years. It's done a hell of a lot of work. Okay. You'll see this sets at 380, I think, 375, 380, let's see. Yep, 382 for, yeah, around 380, just over, okay. This is the tip I use. I find this type of handle very good because you can get much closer to the bottom. You hold it down here. This is the BC3 tip that I use, the big chunky one, okay. And then this is my other soldering iron. This one's Sugon T26D. This is a C210 clone. Again, you'll find you're holding this down here much closer to the end of the tip. This gives you a much more steady hand. You don't want a soldering iron where you're holding it here and the tip is like half a mile away from you, yeah, because any shaking is much amplified. That is just physics. Get yourself something like this if you don't have. And finally, the solder. So this is the mechanic. This is the 0.2 millimeter. I'm not sure if it has a model number on. Oh, TY-V866. I get this from AliExpress. And this is the other one I use, mechanic. This one, HX-T100. This is 0.6 millimeter. I find these two solders very, very good. If you're struggling to do this after some practice, the chances are it's the solder you're using, or the flux you're using, or it's the soldering iron you're using, or you're just not getting the board warm enough first before you start. Okay, so that's a bit about the equipment. Hope that helps you guys. Now let's have a look to see how it went. And there is the finished job. I've just cleaned this up with a bit of isopropyl alcohol. That's looking pretty good to me. If I just tilt it slightly, we can just get a bit of white down the side of it as well, maybe. Yeah, that looks good. I'm just looking to see if I have a bridge here. No, I don't. There's a clear gap there. Okay. I mean, that pad may well go to this resistor anyway, but it's not a bridge. I can feel the gap at the end of the probe. This side, this top one. Bit more of an angle. Yeah, I'm happy that's soldered, but you know, if you wanted to, you could come back in with a bit of flux, warm it up again, just get a little bit more solder on that pad. But personally, I'm quite happy with that. We can compare this with a factory fitted one. Yeah, we have one here. Obviously, a bit better that is factory fitted, but I think you'll agree that that one and the one that I've soldered look similar enough. So I'm happy with that. Soldering videos are probably the most divisive ones I make, shall I say, based on the comments I normally get. That's the way I've learned to do this. My opinion is, as I say, you need to practice. If you don't practice, you can't do this. Get some scrap boards and practice. I think if you spend an hour doing this on a few different chips, after an hour, you'll have a good idea of how this is going to behave. A little bit longer, and probably within a couple of hours, I think you'll be proficient at this. So you do have to spend a little bit of time. I guess it depends person to person. I tried a few different methods before I came to this one, and so far this works for me. But I'm sure you, some of you, will have your own ways of doing this. Get into the comments because it helps us all. But if you feel your version or method is much better than this one, or just better than this one, let us know why it is better. Okay, so guys, get yourself a little bit of work to do there. Get some scrap boards, get practicing. The rest of you, get typing. And I look forward to seeing you all soon on another Learning Electronics Repair video. Ciao for now, guys.